Okay, I am Sumomonga. I'm going to introduce kangaroo method. Okay, thank you. So what is kangaroo method? It is a fast algorithm for searching. It calculates the next point to search by dividing the difference between the aim of the key and the current key by the biggest difference of the adjacent key. The efficiency depends on the structure of the data, but it is as efficient as binary method when the data is sorted, and the difference between the two adjacent keys distributed with uniform distribution. The data must be neat, but it's not necessarily be sorted. That is a brief explanation of kangaroo method. Okay, there are searching algorithms other than kangaroo method. I just briefly tell that. Binary search. It is used for sorted data. It calculates the median point of the array and compare with the searching value. This is a rival of the kangaroo method. But there are many good points for binary search, and it's very useful. But kangaroo method is sometimes compatible with binary search. Tree and hash are something very different from kangaroo method, so we are not going to really see that in this article. Okay, so how to do the kangaroo method? I'm going to explain it. First, we calculate the biggest difference of two adjacent keys. Then search from the beginning of the array. Calculate the difference between the current key and the key which we search for. Divide the difference calculated in tree by the value calculated at 1. When the quotient is bigger than 1, move forward by the quotient number and go to 3. When the quotient is less than 1, move forward by 1 and go to 3. That's the way how to calculate the kangaroo method. Okay, let's see the example. Suppose there are data as 1, 4, blah 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 blah. The biggest difference of the adjacent key are between 57 and 89, and that is 32. Okay, let 111 to be the value to search. The first value is 1, so the difference is 110. So the quotient is 3, so move forward by 3 and reaches to 20. The difference is now 91. So move forward by the quotient of 91 divided by 32, which is 2, and reaches to 31. The difference now is 111 minus 31, so which is 80. So move the quotient of 80 divided by 32, which is 2, and reaches to 57. The difference is, okay, it's gonna be same. So, okay, it's very difficult to understand if I'm just saying. So let's see the example by program. This is how to calculate it. Firstly, calculate the difference. This is the array I used in the presentation. The difference is 3, 6, 10, blah blah, and the biggest is 32. So the biggest difference is 32. First, let's set the first searching value to 111. Firstly, we begin with the first value, which is 1. The difference with 1 and 111 is 110. So the amount to move forward is 3. So 1, 2, 3, and go to 20. Now, let's calculate the difference. It's 111 minus 20, which is 91. So the quotient is 2. So move to 31. So when it is 31, the difference is 80. So the move by 2 and blah blah blah, and we can reach to 111. It will not cross over the searching value because it's divided by the biggest difference. Let's see the next example. This is searching, and this line indicates the searching point. The green is kangaroo method, and blue is binary search. Binary search jumps around, but kangaroo method just steady moves. It jumps, but it doesn't cross over. It converges as fast as binary search. Let's see another example. This is when the data is sine curve. Of course, if you know about binary method, you should know that it doesn't work for sine curve because it must be sorted. The data must be sorted. But the kangaroo search, you don't need. You can actually use it to find the intersection point. So this is very good point for kangaroo method. Kangaroo method's merit, especially comparing with binary search. There's no regression, so you don't need to go back from the go backward. That is good for searching when if the pointer cannot go back. It's not needed to know the end point. So you don't when you do the binary search, you need to know the end point of the array. But in kangaroo search, you don't need to know. The data must be neat, but it is not necessary to be completely sorted. So, you see the sine curve example. The curve was not sorted, but the kangaroo method can lead to the searching value. If the data is neat, it is efficient as binary search. But there's bad point for kangaroo method as well. The biggest difference between the two adjacent key must be calculated. So it takes as much time as the linear search to do that. So the biggest difference must be known from the beginning. The second point is efficiency depends on the data. For example, if there's a huge difference between two adjacent keys, then the search will be very inefficient. Okay, so let's move to another example. Kangaroo method is initially created for the image algorithm. So it can calculate the intersection points between polygons and various figures. As an example, let's calculate the y-axis of the circle. This is the first point, and this is the y-axis. It moves very fast when the point is far from the searching value, and when it is getting closer, it moves less. And it doesn't jump over the value. So you can find the intersection point very efficiently. Thank you for watching.